this computer. So first, before starting, today our presentation is related to the robotics topic, and I'll be sending you by WhatsApp, but sorry, uh, via chat the PowerPoint presentation that I'm going to share with you right now. So just confirm me if you can see the PowerPoint. Can you please do confirm me if you can see the
Yes.
PowerPoint?
Yes, I'm able to download it, sir. Yes.
And you can see it on my screen?
Yes, we are able to.
Okay, great. So today we are going to explore, I believe you are new for MBO2 as a technology in robotics. And before going into detail regarding the technical part of the software and the robot, it's very important to understand the environment of the topic robotics at school, because sometimes we miss some points, and we by missing those points we will not be able to reach let's say what is the goal or the perspective of what we are aiming for. So this is why, first of all, we know since years, like 5 years back or maybe more, all schools are searching to teach robotics. It's like something that everybody is asking, but there is some misunderstanding, because all around us we have like clubs that teaches robotics, and at school we have some requirements in terms of number of students, in terms of time management, in terms of hardware. So the main question that we have to ask is what to teach in robotics in a classroom, in a curriculum. Can we do the same thing that we do in a club after school activity, or there is some restrictions and we have to adapt to so I'll try to answer all those questions tonight in order to make you feel confident regarding this topic. So I will move to my second slide to inform you that tonight we are going to explore the different layers to teach robotics to teach robotic at the school. Okay, and the five layers that we've discovered yesterday with microcontroller are applicable here in robotics also. And as I said yesterday, if you remember well, that when we started teaching Arduino, I told you yesterday that it has to be uh, divided into five main separate layers. I mean, students should take separate parts or separate topics, each topic alone, for what we call the introduction to Arduino, the hardware, the software, connection to Steam, and competition. And here also in robotics, actually, it's almost the same, where students should know the environment of the robotics in order to understand well this science. And then we will be moving to the hardware. And after the hardware, we move to the software. And then later on, we will be exploring how to connect robotics with with the STEAM by creating 3D design. And finally, we will be exploring also the Make X competition in case it will be done in Saudi Arabia. So you will be able to participate to it. So first of all, as I said, and this slide is very important because it shows the 5 layers to explore today with the MBO2 robot, which are the general introduction, the hardware, the software, the connection with Steam, and the connection with MakeX competition. And from here, I can move to slide number 6, where I will start my introduction with the general introduction. And here I ask you to visit in a regular way the platform 01.education, because to this platform always we are adding new resources, new topics, new extra worksheets in order to just give me 1 second. Add to add to platform extra worksheet for intro layer to robotics. Okay, so it's very important to visit, as I said, from time to time, the platform in order to make sure that it is updated, in a regular way. So to make student understand, so we will be uploading on the platform let's say a worksheet in order to do it with your students, to make sure that the general introduction is well assimilated by students. That's why, to make students understand the world of robotics, we should connect it to the real world by creating a dialogue in the classroom. And this dialogue should lead by asking questions to evaluate the knowledge of the students, show them YouTube videos, oral and written assessments is a must in order to make sure that they can reformulate or rewrite those introduction or those questions or those interaction in a correct way. And some of the questions that you might ask your students is to define a robot, where we can find a robot in real life, what are the elements of a robot, which are the skeleton, motor, sensor, brain, and software, the difference between an educational robot and a real, sorry, and a real robot, which is the precision. Just 1 second. I don't know why my keyboard is not writing. Precision. And 5, why we can't consider the washing machine as a robot, etc., etc. So on the worksheet that we are going to upload on the platform, hopefully this weekend, it will help you a lot to guide your students in terms of technicality and to make sure that they understand. So all those questions should be a kind of dialogue between you and the students in order to understand the first layer, which is the general introduction. When I move to layer 2, I'm talking about the hardware, and you will see the MBOT2 robot that you have already at school. that this robot, which is a simple robot, but at the same time, it's a really powerful robot. It includes, sorry, the CyberPi that contains a microphone, a light sensor, a joystick, an inbuilt infra interface, button A, button home, button OK, colorful LED display, Wi-Fi, Bluetooth, and other sensors, sound sensor, the microphone. The microphone is here already. Okay, so this CyberPi, it's built in on the robot, but at the same time, I can detach it from the robot in case I want to perform other manipulation separate from the robot. Because this CyberPi, what I can do with is I can connect it to a set of input and output devices such as the ultrasonic sensor, the dimmer. Uh, just give me. Okay, so I can connect to my CyberPi ultrasonic sensor, DC motor, servo motor, dimmer, lights, and other sensors. And this pack comes with an extra kit that is the CyberPi Innovation Add-on Pack. And then after, this CyberPi can communicate with my robot and could be programmed in an amazing way that you cannot imagine. So on this LCD screen, you can do a game, you can generate a graph, you can generate an Excel sheet to collect data. So it's a powerful mini supercomputer. And to know that this CyberPi, you can, as I said before, you can connect to it a smart camera, a set of sensors, ultrasonic sensor, and many other items. And then I come to the robot by itself to tell you that this robot is formed of actually the CyberPi that is connected to the main processor that includes a battery. You have two encoder motors connected to the skeleton, and you have two sensors, which are the ultrasonic sensor and the color sensor. So this is the basic model of the robot. And note that this encoder motor is powerful, and it contains a sensor that includes the option to make the robot move within a specific distance and turn specific degrees in a precise way. Then after I move to the ultrasonic sensor, which is the version 2. It contains here on the LEDs lights that can display emotions for the robot. And I believe this will be very important for students for as interaction and motivation. For the quad color sensor, please note that you have the inbuilt port to connect this sensor to the robot. At the same time, you have what we call the light sensor or the color sensor, which are left two, left one, right two, and those are what we call a fill light in order to give an ambient light for the robot according to the place where we are experimenting those activities. After that, you have inside the robot a sensor that we cannot see, which is the gyro sensor, where you can detect what we call the deviation of the robot. So you have the Z-axis, which is the pow. So if the robot will turn to the left or to the right, it will tell you actually if it's drifting or shifting to the left or to the right. You have the pitch, which is the X. So it shows you that if it's go down on a or climbing a hill, or the roll axe, which is the third sensor, in order to uh, detect all the movements. After that, we go to the software, which is a really simple interface that the student will enjoy, which is scratch based, that you can see instead of the cat, you have the panda, and you have same the sprite and the background, but additionally you have a layer called devices, and same like the programming in Scratch. So you can do here the programming in order to make the robot executing. But of course, there is some specific, like some specific modification on the software, because you have here the connect to the robot, you have the upload file or the live mode, etc., etc. So we will go back to the software the moment I finish this presentation. Once the interface is done, I can move to and here I forget to say that we are in layer 3, which is the software. So if I go back to the beginning, remember that layer 1 is the introduction, layer 2 is the hardware, layer 3 is the software, layer 4 is the connection with Steam, where you can even add a pre-made models in terms of changing the functionality of the robot. So you can see we can add an arm, we can add like a box in order to transport objects and to consider that the robot is considered as a track. And all this comes with a kit or called the Smart Word add-on pack, where we have 3 models that you can build easily. And then after, I can create extra models using the 3D printer. And here I'm showing you a model made with the 3D design Tinkercad, and it was printed on the 3D printer, where I can connect my robot from left to right. This bridge, I can connect it to the robot, and in this hole I can, or box, I can insert a servo motor. After that, I can connect or I can print like those items in order to add them to the servo motor in order to create an extra activity. So here we are talking about, as I said, layer 4, and still remaining the layer 5, which is the competition make X. So here I will not take action before I make sure that this competition will take place in Saudi Arabia. So this is a general overview about the just one second, about the robotics 5 layers, and then I will close PowerPoint and go directly to the software M block. So the software M block will be launched. And here I will ask you to make sure that you have the version 5.4.3. If it's not this version, so it's better to upgrade to this version. Maybe you noticed that automatically on the device you have the mbot 2. It's correct because I did this setup in order not to each time I launch my software to add it manually. So this is why I will show you. I will close. I will delete this. I will the MBO2. I will add. So basically, when you install, and this is very important for practice, when you install the first time the M block, you will have your screen like this. I mean, in devices, you will have the CyberPi. You are invited for a better process for you and for the students to make some changes by deleting the CyberPi, by adding the mbot 2, okay, and by clicking on blue uh, this blue star in order to make this robot as a preferred or the most usely device. So I will click OK, and every time you will launch this software, you will have the MBO2 displayed. So in the computer room, please do this setup, but it's not available on the previous version. You have to reinstall or to update the software in order to have the version 5.4.3. Okay? And you consider or you can see that once the robot is added, so you can see that you have a category called audio, LED, display, motion sensing, LAN, AI, IoT, all those categories are related to the CyberPi. And if you see the shape of this icon, so actually it's the shape of the CyberPi. So from here, I can say that it is all the categories are for the CyberPi. If I scroll down, I can see that I have events, control, operators, variables, and blocks, which are the categories common with Scratch Junior. So nothing new in those categories. And scrolling down, I can see that the MBOT chassis, MBOT extension, quad RGB, and ultrasonic sensor are related to the robot by itself. So why I'm focusing on this point, because you have to know that there is a difference between the blocks or the category of blocks for the CyberPi and the category of blocks for the MBO2 robot and its sensors. Now, if I want to, let me see if I can open my video, my camera. All right. So here is my robot. Okay. It's connected already to my computer via this USB cable. So all I have to do is to click on connect. Here it will shows me the port that I'm connecting. If I click on connect, So now my robot is connected. Okay, and I have two options. The one is live.
I'm sorry
Yeah.
to interrupt, sir.
Sorry?
Just is it enough? Yeah. Just one question. Is it enough if we just connect it, or do we have to do any sort of pairing between the devices?
No. The connect is pairing.
Okay.
All right. But
Okay, sir.
here,
Yeah.
but here you have two options. The first option is to go live, and the second option is to go upload. And if you want to ask me what is the most suitable, let's say, method to work in a classroom, I can tell you that it's better to go for the upload, because on this robot you can upload program 1, 2, 3, 4 up till 8, and then at the end you will be trying to test them at the end of the period for all the students.
Okay, so it is unlike a microbit wherein you can store only one program. Here we can store eight programs, isn't it?
Exactly.
Okay.
So here it's a bit different. Uh, it's a bit different here from the microbit. Okay, but here I have to show you, because it's a little bit critical when we save and we upload. So let us try a simple program. I will take the event. When I push on the when I select, I move the when the button A is pressed, I want, let's say, to play the LEDs, then to to wait 1 second, and then after with the LED, turn off LED, and then play high, and then I want my robot to move forward for 1 second. It's a simple mission. Imagine that a group of students, of two students, did this mission, and they will ask you to upload it on the robot in order to try it. So what I'm going to do is I will click on the upload button. Okay, I will I will click here on the untitled. I will type it, let's say, Dome. I click outside, and it's rename success. Then I go for file, save to your computer, and not save as, because if you click on save as, you will be asked to log in to the cloud and to upload the mission to the cloud. So it's not our case. So remember, and this is a common mistake that students will do, file, save to your computer. And then I will save DOM to my computer. And after the saving, I will click on the upload code. And it will take like few seconds, and the program will be uploaded. It's taking more than expected. It's oh my God, it was off. My robot was off. Excuse me. Okay, so I will disconnect. I will connect again, and then I will go to upload code. So look here, the program is uploaded, and that's it. So I can remove the cable, and I can see that my screen is black. So I have to click on this button, which is the home button next to the USB cable, to charge the robot and to upload. Then I click on the home button. You can see the screen is on. With the joystick, I go down to the switch program. I push my joystick, and I can see that the first program is Dome. I don't know if it's clear. I click on Dome, Now the program is waiting me to press on the button A. So if I click on the button A, look at the, okay, I will press again. So I press and the robot is running again. And that's it. So the moment you are aware about how to, sorry, please. The moment you are aware on how to connect your robot and upload your robot, it will be an easy task for you, because creating missions will be a fun, since it's almost the same as for the for Scratch. Now let us let me show you, for example, a simple mission on how my robot will stop in case it will face an obstacle. Okay, so first of all, I will delete all this. I will keep my button A. Then I will ask my robot to move forward at a speed of 20. Okay, without precising the duration and the distance. Okay, why I ask my robot to move forward without precising the duration and the distance? Because from the beginning, I don't know where my obstacle will be. So I ask my robot to move forward, and then I will go for the control. I will move the wait until, and from the wait until, I will add the block from the ultrasonic sensor, which is the ultrasonic sensor distance to an object in centimeter. But actually, I cannot fit it here. They are not the same shape, because I have to add from the operator the block, this block, to make a comparison between the distance measured and the value of the I want. So when I wait until my ultrasonic sensor will read an object less than 10, so here I can ask my robot from the MBOT chassis to stop the encoder motor. And that's it. So I will connect my robot. I will open my camera. I will connect my robot. I will go live. It's better since I'm holding the robot. I will click on connect. Then when I press on the button A, look how the robot is moving forward. And the moment I approach or I move my hand, it stops. So it stops. Why? Because the ultrasonic sensor detects a distance less than 10. I will play it again. And so look here, it's approaching, and stop. So this is how I can control my robot using the sensor. And
so the distance between that your hand and the sensor, that distance, can it be controlled by us?
sorry, I did not get the idea.
The distance,
Yes.
between the object and the sensor, can it be controlled by us, or is it fixed?
No,
Say,
no, 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 no. You can look here. You can change the value you want.
okay. Yeah, I'm just
You can,
seeing the looking the code now.
you can
Okay.
change. If you want to create, for example, another mission, creating another condition, like, for example, if you want to upload like this because it can detect sound, so you can go here to the I think to the audio. Let me remember. To the sensing, okay, and take the loudness sensor and replace it here. And when the here my loudness, you can see it here. It's when I talk, the loudness is very high, and when I silent, it's almost 1, 2, or 0. So if it's greater than let's say 50, sorry, if it's greater than 50, then the robot will stop. So look here, I will click on the button A. Is greater than 50, sorry, excuse me. So where is the operator? Greater than 50, not less than 50. Okay, so I click, and the moment I talk, it stops. Look how responsive and quick it is. So the idea of creating emission using 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 the sensors, it's almost the same. Okay, and if we want to go through those blocks or categories, you can see that here you have the audio, here you have the LED, here you have the display. So the audio is related to everything audio, the LED for the LEDs, the display in order to display a specific message on the screen. The motion sensing are all sensors related to the movement of the robot, from tilting, shaking, waving. The sensing, which are normal sensing, like the joystick, the push button, the button A, the button B, the loudness, the ambient light, the timer, the battery level. LAN, AI, and IoT are not considered as let's say uh, uh, sorry, as in the program. The event, the control operator, and variables and my blocks are related to the program by itself, like in Scratch. And then the mbot chassis are for the blocks to control the two wheels. The mbot extension, for the time being, it's not used because you have to add additional motors for the robot in order to use this category. And for the quad RGB sensor and the ultrasonic sensor are the blocks for the two sensors. So I believe that I believe that it's going to be for another time of training. The moment now is to explore the basic knowledge of them and of the robot, and later we will be moving further with controlling more with the sensors. So basically, this is the introduction regarding this